to this Praxis Forum on Industrial and Labour Safety. Please come in and take a seat. My name is Lee Alford. I'm the Operations Manager of the European Process Safety Centre, or EPSC for short, and it's my pleasure to be chairing this session this morning. It's a very short and sharp session. We're beginning with our first speaker, Yuri Nekhamkin from VisiMix Limited. And I'd like to remind all the speakers that it's only 15 minutes plus 2 minutes of discussion time. So without taking any more of your time, I'd like you to start. Thank you very much. Over to you. Thank you.
Thank you. Good day. My name is Yuri Nekhamkin, and I represent here a company called VisiMix. This company develops simulation software for different type of mixing dependent process in stirred reactors. And before I start, could you tell me who is familiar with this software? Okay. Not much, so maybe I repeat some items that are known to you good enough. So, just a moment. We will discuss today some questions, motivation, background, and if we have time enough, I prepared 3 examples of VisiMix application. One is for solving safety problems at the design, at the design stage, second during operation, and third for accident investigation. In case if we have no time enough, I will invite all of you to our stand, and I'll show you everything in details there. So let's start with introduction. As I have already told, VisiMix software was developed for process engineers as a computational simulation tool for solving different types of technological problems in stirred reactors, really. VisiMix gained recognition because it provides adequate and rather complete description of different processes in stirred reactors, and it's very important accounting equipment configuration, parameters of the process and properties of the materials. And this software is based on reliable models, many times verified in practice. Any details can be found at our site in VisiMix, and this is also a description of VisiMix application and its story. And this slide shows some of our customers. What is important that our cooperation exists during several and sometimes many years. We have more than 200 clients, and again, our participation is a service as always, but it's not simple service, it's really configuration. And feedback from our clients gives us understanding of the trends. And one of such results of such cooperation is that understanding that VisiMix potential enables to enhance field of application of VisiMix to improve safety characteristics of the considered stirred reactor. It means that VisiMix becomes an efficient tool for safety engineers during, again, at the stage of design, at the design stage, again, sorry. Design stage, operation stage and during investigation. Motivation. Stirred reactor belongs to the key types of the chemical equipment. And its operation, according to statistics, is followed by 14% of total accidents in chemical industry, and majority of them are connected with batch, semi-batch reactors, and they are caused by different reasons. So any tool that is able to predict, prevent such accidents is useful for chemical industry. And the second element of our motivation is a concept of the inherently safer design that was suggested by Dr. Kletz. And this concept, and now I refer to Dennis Henderson, was the main expert in this field, is first of all to the challenge of the process engineer is to identify ways to eliminate the hazards associated with the process rather than to develop barriers to protect people from these hazards. And second is to use appropriate analytical and decision-making tools to select the best process alternative, considering all these hazards. So it's motivation of this work and some VisiMix features that make our program, in our opinion, attractive for solving this problem. First of all, VisiMix is a set of software tools for simulation and calculation of mixing-related process. It was developed for process engineers, by process engineers, and you will feel this feature, distinguished feature. The set of VisiMix software codes includes, first of all, turbulent flow regimes, laminar, and it considers high viscosity flow and non-Newtonian liquids flow. Variant with different impellers, which really is a supplement to the turbulent version they are working as a couple. VisiMix RSDE for simulation of rotor stator dispenser. It's a new program, and tomorrow at in 4 o'clock, my colleague and friend Yuri Nekhamkin, he will tell you about this program. Pipeline for hydraulic calculations of the liquids in this system. And the last one is Excel that integrates VisiMix reports in a standard Excel form. VisiMix, all this VisiMix set covers the following main unit operation. And as one can see, it includes single-phase mixing, two-phase mixing, including liquid-solid mixing, liquid-liquid mixing, liquid-gas mixing, I forgot to include it, single-phase chemical reactions, mechanical calculations of the shaft, and temperature-dependent reactions, including thermal safety. Second, as I have already told, VisiMix performs calculations with respect to real equipment design and process regime parameters. What is important, selection and input data are inserted by means of selections using windows, small tables, let's say, by means of user-friendly interface. And I will show you this confirmation. This is type of input tables for VisiMix, and this is detailed picture how we selected, and the same is with a huge library of different type of mixers. All the data which are necessary are easily available for process engineers. And in case, if, I'll try to be as fast as possible, in case if there are some problems, VisiMix has built-in databases with properties of all applied materials, and enhanced technical information is available due to help system. But it has an additional feature. VisiMix combines calculation tool, simulation, with expert system. And this expert system sends warning messages every time when the input leads to unacceptable process course. It means that VisiMix enables to define safety range of the basic process parameters. And here you can see typical type of messages. Mixing power too high, complete suspension is questionable, information about possible runaway reaction, and so on. So now, if we recall that any accident or incident starts usually from small deviation from the normal process course, VisiMix message system enables to define in the frame of ISD or inherently safety technology concept a range of stirred reactors. Now example. The first example is devoted to the tackling process, safety process at the design stage. And the actual process consists of two stages. Initial stage, which starts the reaction, and the heating achieved by steam at atmospheric pressure supplied into the jacket. And the subsequent cooling stage, which is necessary to remove excessive heat, and it is realized by supply of water, ordinary water at 20 degrees, circulated in jackets. Yes? The considered process occurs in a cylindrical, fully beveled stirred reactor with a pitch pedal impeller, and this impeller rotates with 85 RPM. It has, the process is based on the exothermal catalytical reaction involving solid catalyst. Yes, it is also important. And the aim of the analysis is to define main characteristics and to define duration of each stage and total duration of the process. So the considered problem from the safety point of view, it allows us to formulate two tasks to be solved. First of all, we must check if our rotation speed is more than minimum velocity, rotation velocity of the impeller, at which there is no settling of the solid particles on the water, no stagnant zone. So the first task was solved using liquid-solid mixing submenu. And we must use, choose parameter, I'll show it, complete incomplete suspension at different variants of rotating speed, gradually increasing this value. And when the rotating speed is less than just suspension speed, we will get, we will get such type of messages. Or it's questionable, or there is partial settling at the bottom. And when they are equal, we got, and it is at 72 RPM, we will get this, such confirmation. What is important is that we have immediately safety gap, because our rotation speed is 85 degrees.
5 minutes, Mr. Speaker. 5 minutes.
5 minutes? Okay. This second stage, simulation of the first stage, initial start, will give us that, inform us that after 7.3 minutes, yes, this is, we will have rotation, runaway reaction. By the way, if instead of steam we will use another heating agent, for example, Dow-Therm SR1, we will have this information message. It means it is caused by the reason that Dow-Therm is operating at this temperature, and for process upper limit is this. So this is temperature history and concentration history of the first stage. And this graph shows that at 7.3 minutes we have runaway, so we can select with a half minute as a duration for the first stage, and use corresponding values of temperature and concentration as initial values for simulation of second stage. Calculations gives us the duration of the second stage is 5.3 minutes, and total duration is 10 minutes. So we solved this problem. And now I'll go exactly to the conclusions, and we will consider other examples a little bit later. So, conclusion. First of all, I would like to tell that process analysis based on justified technical calculations and simulation is a mandatory element of the of this ISD concept. This is the first. Second, VisiMix has proven its capabilities because of the following features. I just mentioned them, but I would like to add one thing, that in addition to the user-friendly interface, and this program calculates everything exactly based on the reliable models, it gives quick results, almost immediate results. So I continue it. This calculation tool and expert system, I think, is a strong feature of this program. And the last time, the next version of VisiMix, we will try to include submenu devoted to the safety operation. That's all.
Okay.
So, any questions?
Thank you very much, Yuri. Thank you.
Thank you all.
I guess the obvious question for me is where is your stand in the exhibition?
Yes, just a moment. Also,
so it's
A33.
A33.
Number
okay.
9.
And you'd be happy for anybody to visit the stand to demonstrate the software?
Yes, we have everything there, and anytime. Thank you very much.
Does anybody have just one more question of Yuri at all?
Just a question. The model you're using, the code you're using, it couples material transport, heat transport, and chemical reaction all together.
And it's very often we get questioned what is the difference between our approach and CFD. I would like to say from the point of hydrodynamic calculations, our program is based not on numerical calculation of these finite elements. It's old-fashioned but very reliable integral methods used up to 70 years of the last century. They were used in aviation, everywhere, and they are very accurate. So, in order to finish.
Well, I'd like to thank you and your team. Thank you very much.
Thank you. And I invite everybody to our side.
Very good.